Hello everyone around the world. Welcome to this Black Hole Pioneer webinar. The Black Hole Pioneer project, or the Black Hole Partnership for International Research and Education, is an U.S. National Science Foundation funded project to support the science utilization of the Event Horizon Telescope. Our contribution include from instrumentation to data processing, theoretical simulation, testing GL, to training and education. So this webinar is the first one in the fall of 2022 series, where we will go through how to use the OSG to perform large-scale parameter survey. So before we start, let's go through some housekeeping items. So first, for the other panelists, please make sure you are mute. I will mute myself after this introduction. And for the webinar attendee, please open up your Q&A window from Zoom, and then you can type in questions during the webinar, and we will try to monitor that and answer that when appropriate. The presentation will last for about an hour, but we have a little bit more time, so if we have more questions, I guess we can stay for longer. Finally, our project manager will post a survey near the end of the webinar to a chat. The survey is very short. Please fill that in because it will help us improve our webinars. So we will have 4 speakers today. The first one is Christina. So she's a research computing facilitator at the High Throughput Computing Center at University of Wisconsin-Madison. She will start by giving us an overview of OSG. Next is Brian. He's also from Wisconsin, and he will describe some of the basic tools. And then that will be me, Chi-Kun Chen. So I'm from the U of A. I will do a demo on how to use the IPO software to perform large-scale black hole simulation. And then Rob Quick, so he's an associate director of the Cyber Infrastructure Integration Research Center at Indiana University. So he will showcase the Science Gateway. So without further ado, Christina, please take it away.
Yep. Thanks, CK. So welcome everyone to this webinar on performing large-scale parameter surveys with OSG services. And the person who's going to kick us off with an overview of the OSG high-throughput services is Brian.
Hey everybody. So my task here today is to set the big picture, set the stage of who we, the OSG are, and what sort of things do occur before Christina, CK, and Rob get to go into the details and why it's useful for the community. So at the highest level, actually, OSG is a consortium. It's a group of people that work together to do something. And if you, in fact, go to our website, we say we're a consortium. We operate a fabric of distributed high-throughput computing services in support of the national science and engineering community. So again, consortium, a set of people that work together. Distributed high-throughput computing is maybe not a phrase that everybody here knows, but we take and utilize compute capacity from all across the US, in fact, with some of our partners all across the planet, and apply this just high-throughput computing style of computing in order to effectively leverage those services or those resources into effective capacity. So we're about taking lots of cycles and effectively delivering it to lots and lots of tasks for science. And then finally, again, we're based on the US and focused on the science and engineering community. So in fact, our funding comes primarily from the NSF, or contributions from NSF funded projects. So for example, the 2 biggest projects that participate and operate OSG services is one called PATH, the Partnership to Advanced Throughput Computing, and IRIS-HEP, which is LHC focused, but again contributes to the overall goal. All right, next slide. So here's an overview of a couple of the major services we run. To put them all on a single slide requires size 6 font, so I would decide to spare you guys. We run computing services. So for example, one important one is the Open Science Compute Federation, which takes these disparate clusters at different universities and groups them together in different pools of resources. Some of the pools, say, are maybe for a single experiment, and some of these are shared amongst multiple different entities. A really important pool of resources that CK used for his work is called the Open Science Pool. And this is largely consisting of opportunistic, so otherwise idle cycles or donated resources, say through NSF computing programs. And the OS pool, one of the reasons we're talking here is actually open to anybody who's a federally funded US researcher or their international collaborators. And then finally, the other one we're going to highlight a couple times today is this idea of an access point. So this is a service where users can come up, they can place their workloads, their data, their jobs, and then that access point is responsible for leveraging the compute capacity, say, in a single pool like the OS pool or across multiple. All right, next slide. So just to give a feel for the breadth of who participates, and here I did actually purposely put in very small font so I can make sure that we had our sites in Arizona here, because I understand we have a couple Arizona participants. So this is some of our compute and storage services. It's over 120 universities and laboratories across the planet, about half inside the US and half outside. Moves about 90 million files a week, runs about 2 million jobs a week, does about 1 million or 2 CPU hours a day in these different pools. And there's about a dozen different access points across the US. Not all access points are built the same. So for example, the one that CK used, Christina will talk about later, is called OSG Connect. And that's kind of for the broad open science community, whereas other ones are maybe specific to a single experiment, like the Class 12 experiment at JLab in Virginia. All right, next slide. Again, this core concept for today in this seminar is the access point. This is where you place and manage your workloads and files. Some of you might look at this and say, hey, wait a minute, this is just a login host or a submit host for the cluster. And that's true. It is, we'll be demonstrating at least partially, say, a SSH-based login. But we think of it as an entire suite of services, not just the batch system, so we use the HD Condor software suite, but also services for moving files, managing users, managing quotas, kind of the whole integrative set of services. You know, these access points, you know, is your home on the set of OSG services. All right, next slide. Again, to be useful, you not only need a home, but you need some horsepower to do your work. I mentioned the OS pool before, and that is part of that larger compute federation. It's about 70 different compute resources at the peak. That's governed by fair share and open for anybody. There's a new facility called the PATH facility, which is actually operated by the PATH project. Its resources are allocated by the NSF and based on credits. And some of you might be familiar with Exceed, which is actually now transitioned to the Access project. And the access point can also utilize resource providers within Access and use your access allocations there. So that the idea is you put all your work at the home, and then you think about what different compute capacity you'd like to access. Next slide. And just to kind of give an overview of how this is interconnected within the NSF community, you know, not only to have a current record of 74 universities in that one single resource pool contributing, but really interesting or important subset is the 30 sites that have received compute clusters to the NSF CC Star program. So it's not just opportunistic, here's an idle cycle, kind of SETI at home style but for university clusters. But some of these sites are funded by the NSF and have a responsibility to share compute resources through the OS. Next slide. And I'm gonna now hand it off to Christina to dig in a little bit about what it's like to live and work on OSG services.
Yeah, thanks, Brian. So Brian has kind of given an overview of the kinds of services that the OSG Consortium operates. So we have the access point, we have capacity, we have some data tools. And so I'm going to talk briefly about two kind of specific tools or services before we get into our examples for today. So Brian already mentioned OSG Connect. These are OSG operated access points for placing and running workloads. And that's, we'll see these access points used later in today's webinar. And this is where, by default, if you get an account on an OSG Connect access point, your work will run in, also previously mentioned, the Open Science Pool. So this collection of resources from across the US and beyond. And you can also plug in this additional capacity if you need. So this is kind of a specific service that you can use. It's accessible using kind of your standard SSH login, either via the command line or a tool like PuTTY. If you're using the access point to manage your workloads, you'll be using the HT Condor job scheduler. More on that in the next slide. And the access point, so besides accessing capacity, managing jobs also has some space for data or files that you're using as part of your workload, and different tools for either accessing the data and using the data that you have on the access point or potentially in other places. And so OSG Connect, as an access point, has all of these services available to you. So next, I want to focus on this HT Condor job scheduler. HT Condor is the job scheduler used on OSG services. In some ways, it's going to operate like other scheduling tools. There's a submit file with its own syntax and commands to submit jobs. But what I want to highlight is really, and I think you'll see it in the demo as well, the submit file is a way of capturing important information about your workload. So I think it's helpful to think about, what am I running? What are the components? And then how do I put them into the HT Condor format rather than the other way around? And so components you'll want to think about when using HT Condor and running in a distributed way are your main executable, any files you need. That could be input data, could be software packages, could be additional scripts. Knowing how many resources and what kinds of resources you want your jobs to use. Do they have any specific requirements? How big is your workload? How many tasks do you want to run? How many jobs do you want to submit? And any other options or information that are important to your job. So I don't have an example on this slide of what the submit file looks like, because we'll see an example in a minute, but I do want to encourage people to think about, you're taking these sort of important information about your workload and then putting it in the Condor format, rather than just kind of like trying to spontaneously generate a submit file. And so, this big catalog of services, these specific things, they're here for you to accomplish your work. So do you have a big workload of tasks? You could use the OSG Connect access point to place your workload using the OS pool and potentially other resources. If that sounds a little intimidating, and or if what you're running is already in place, you could use, do you want to use something like a web interface to run specifically some of these iPool calculations? There's now a gateway service that's using the Open Science Pool behind the scenes that can do similar kinds of work. And then, if you have allocations on other resources, that's something you could bring to the OSG Connect access point and use could place your workload there and have your jobs run on an allocation. So hopefully attendees on this call or people watching the video later you can see yourselves in one of these scenarios to see kind of that might work for me in the work that I want to do. And we'll, at the end of the talk, at the end of the webinar, we'll go through next steps for getting started on each of these. But for the rest of the webinar, what we want to do is actually show you what it looks like to do these, so you can really see what it would be like to either use OSG Connect to submit and run some jobs, or to use a gateway interface to run a survey of these IPOL calculations. So after the next slide, that's what we'll be doing. But to launch us into that section, why do this? You know, what motivates us to either use the access point or the gateway or get these allocations? It's because we want to do a lot of computing, probably. I'm guessing that most of you have big computing problems. And so the amount of capacity that's available in the Open Science Pool through the access point is significant, and you can just run a lot of things. In the past year, the EHT project has run over 3 million jobs on the Open Science Pool, so that those have been managed by the access point. And a lot of that happened in a 2-month burst of computing. So it's really possible to manage and run these big workloads using the tools and services that we're going to talk about. So hopefully that's inspirational for everyone. And with that, I'm going to turn it over to CK to do a demonstration, to talk about some intro information and a demo.
Thank you very much, Christina. Maybe I can share my own screen so I can go back and forth. Yep. So, okay, so let me share my screen and show you the slides again. So, yeah, so, thanks everyone for calling in. So the science use case I will show is about the Event Horizon Telescope. So I guess many of you have seen this picture here. This is not the first image of black hole. This is the second one that we released a few months ago in May this year. This is the black hole at the center of the Milky Way. But the EHT is not just a project that takes a picture. We also have Science Tonight Station. We want to learn the astrophysics and the physics behind the black hole. So we have a lot of computation job that we need to do modeling simulations of black holes. And in order to do that, we use the OSG. And just to let you know, when we were preparing the publication of this image, we actually spent a lot of time on the OSG. And this was a Twitter post by Faria Ocel last year, I think almost a year ago now, that we actually pushed the OSG burn rate to record high, and we were the leading user at that time. And this is one of the bursting run we did to generate the simulation library that I will show you later that lead to the science discovery we have. Okay, so in the EHT right now, we have 4 different pipelines, 4 different kind of workflows. We use the OSG. The first one is to compute a black hole image. So these are general relativistic ray tracing calculation. So what happens is we follow photons from a virtual screen back to a simulation of accretion flow, and then we solve the radiative transfer equation along this geodesic. And by doing so, we can compute how an image of a black hole will look like. So the main tool we are using is IPOL, and then we just develop a contour script to manage many IPOL jobs. Now, another calculation we need to do is to compute the spectral energy distribution. So this is how much E&M emission we get from the black hole across a wide range of wavelength. So the tool we use is called GR-Monty. And again, we have another set of script that control the workflow. And once we have many of these simulations, we need to do analysis. For example, we want to know how big is the black hole image. So we have another tool that is based on EHT imaging that we use to estimate the black hole size. Now, this is a pretty interesting workflow because it's based on a Python package. And you may wonder, how do you resolve your Python dependency problem across all the different supercomputers across the US? So the trick is to use container technology. OSG actually support using Singularity container. You can synchronize your container with OSG, and then you can have the same environment across all the workloads you have. And then the last one here, we have a simple workflow that creates synthetic data. So the idea is we take these simulations, we do a virtual observation, get the so-called visibility data, which is the data we observe from the DHT, and then we do calibration on this data and get a data set as close as possible to the real observation. So we use this to calibrate our analysis and also help us plan the next observation. So this is a more advanced pipeline because we need to interface with Cyverse on the data. So we use Pegasus to manage this workflow. The workflow will automatically pull in input data from Cyverse, do the calculation, and send the data back to Cyverse. So these are the four use cases we have now. But we are working with OSG to add a lot of new features, including secure data transfer. So I expect we will use the OSG to do data analysis of the real observation data in the future. And another thing I forgot to mention is for the IPO calculation, they are quite small. So they fit naturally to a one-core job, and we can run many of them. But the GL Monty job, they are more computationally more expensive. And in order to take advantage of the many computation resource provided by the OS pool, we actually split the job into 16 sub-jobs, and then we gather the data and combine that at the end. So this is more work when you develop your script, but at the end, you will be able to get a lot more computing resource otherwise. So I remember the record I got for running GL Monty calculation is 16,000 cores at a time. So I think that's pretty impressive. Okay, so I already mentioned this a little bit, but it's always useful to have a graphics. So when we are doing this IPO calculation, this is the physics we need to include. So first, we need to assume general relativity. We need to assume the space-time metric. And then we perform the so-called general relativistic Melito hydrodynamic simulation, which gives us the dynamics of the accretion flow. But just having the dynamics is not enough. We also need to know the electron temperature and all the thermodynamics. To be honest, we are not in very good at that point yet. And I will say the electron distribution function is one of the biggest uncertainty in our calculation. And that is the exact reason why we need so many computation power to survey through the parameter space in order to really know what we are looking at. So we have this plasma prescription with a lot of different parameters. We combine that with the GL-MHD calculation, and then using IPO or other ray tracing tools like G-Ray, we will be able to get a black hole image like this. So for IPO, it was developed originally by Monica and Charles. So I have a reference here. And a lot of students at Illinois have did a lot of improvement over the years. And the latest paper summarizing all these improvements is by George Wong, also cited here. Okay, so after you set up IPO, send that through the OSG and do all the calculation, you will get simulations like this. So this is one of the simulation. It's a movie because we are doing dynamic calculation and with a certain parameter. So I can explain this later. But just having one simulation is not enough. So we start changing the inclination of black hole. We ask if we look at the black hole at different inclination, how will you look like? So this is that. And then we say, but the black hole can have different spin, right? So we include the spin as a parameter, and then now we have expanded the library further. But we are still not happy. We just said, the electron temperature is the biggest uncertainty. So we allow the electron temperature to vary, and we have that. And the last part is we allow to have different magnetic field configuration. And this is part of our fiducial simulation library, all the things you see here. And all of these calculations were done on the OSG. Okay, so this is a long movie, and let me just skip this. Okay, so let me go through a little bit of how to set up IPO. So IPO is a C code. You can get it from GitHub at the Illinois Astrophysics Fluid Dynamics group repository. So that is the link. And then on the OSG, I actually recommend compiling it with static linkage. The reason is, well, after you get rid of all the library dependency, it's much easier to ship it to the different worker nodes. But if you don't want to do that, if you still want to use dynamical linkage for other applications, you can also use container like Docker or Singularity to make this work. And I also want to say Singularity container was recently changed to become Apptainer. So this actually gives us some problem running jobs on the OSG. So when you try that, you have problem, just reach out to us, and we are figuring out how to resolve that problem. So once you have the code, you need input file. For input, we need these 3-hour MHD simulations. We have a couple of samples on OSB Connect already. So if you just follow this demo, you will be able to get this data and run your job. And then in addition, we also need a parameter file for IPO. It's just a text file describing how to change the different configuration, like the inclination, how many pixels you want in your image. And then the output of IPO is a black hole image in the HDF5 format. Okay, so that's IPO, but in order to run it on OSG, we have a encode workflow. In some sense, this is not really a workflow. It's just a bunch of script that make your job submission easier. So you can clone the clone the repository from here, and it contains a directory structure for you to stage the input, output, and log file. And then you has a wrapper script to turn command line argument into an IPO parameter file. So make things much easier to work with the OSG. And then the main script in this repository is a HTC Condor submission script that Christina already mentioned. So in the demo, I will show you how that looks like. And then we also have a bunch of other scripts that help managing this very large job. And another interesting thing is, because the data is sent through the internet, right? This is not a HPC interconnect within a data center. You actually go through the internet. So time to time, you may have file corruption, especially when you run a job as big as the EHT need. So in addition to all the script I mentioned, we also have checksums to our input and output files to make sure that our jobs are done properly. So I saw a question from Angelo in the Q&A. How annoying would it be to also do M unit fitting on OS pool? So for the people who are not familiar with this, so the GRMHD simulation, they are scale-free in the density. Well, this is just fluid dynamics. So the density in your simulation is just an arbitrary unit. You can rescale that. But when you compute the black hole image, that scale actually matters, because if you have too much matter around the black hole will become optically thick, and then you cannot see the central hole. So we have a procedure before running this job called the M unit fitting. The idea is to search for the normalization of the density in order to get the right flux for the final image. So right now, this is done on HPC. The main reason is you can do this fitting by downsampling your simulation. So you actually don't need that many calculations, and using local HPC resources is good enough. But Angelo, to answer your question, I think all you need is to set up a number of scripts to do this automatically. And once you have that, it will be just as easy as typing a command. Okay. All right, so I talked a lot, so let's now go to the actual demo. Okay, so let me make this bigger so that people can see this. And thanks, Rosie. So Rosie just post a link to the IPO OSG repository. So this is the repository that Rosie just posted in the chat. So let me go to my terminal. So the first thing I want to do is to SSH to the OSG Connect login node. So this is my home directory. I have some directory structure here already. So usually I put my source code within SRC, and I already get IGL Monty and IPO here. But just to for the purpose of the demo, let me also clone the IPO repository again. So let me call this IPO demo. Yeah, I messed up. This is changed. What if I changed different name? Okay, I think the reason is because on the login node, I don't have my SSH key set up correctly. So let me try the HTTPS route. Okay, it's working. So I have the IPO demo source code now, but earlier I mentioned that we want to do things in static linkage, right? So let me go to my original IPO source code and show you I actually changed the Makefile to enable this static linkage to make shipping the binary easier. So let me go to my, and I just figure out I have a typo, so let me fix that. So in this new demo, let me just copy the Makefile to here. So now I have the right configuration for the static linkage. And then I also need to load the proper library. So I know the new scientific library in HDF5, and now I can compile IPO. So because I enable all the warnings, so you do see some warnings, but don't worry about that. And because of static linkage, if I check my binary, I shouldn't have undefined symbol, undefined reference. All of these are actually inside the binary, all the symbols. Okay, so now I have the static linkage binary that I want with IPO. Now I can go to my runs directory and let me start cloning the IPO SG repository. And let me also make sure I use HTTPS. Okay, and I think in order for this to work, I need to put it in a specific name because my submission scripts are trying to be smart and automatic and figure out what kind of job I want to run. So let me clone this repository by this very specific name. So I want to do a imaging survey, simulation imaging survey with the magnetically dominated accretion flow with positive 0.9 spin in window 5 and at the EHT observation wavelength. Okay. If I do that, now I go into here. You see this different directory structure to stage your output. And let me go into the bin directory to just go through some of this. The first thing I should do is to copy the IPO binary that I just I just generate. So let me do that. IPO demo, IPO here. Now, the second thing you should do is you need to find out what is the checksum of your IPO, and then update. Let's see, which file should I update? I think I should update wrapper. So yeah, so there is a MD5 sum here that I need to change to my latest one. So I do think for OSG, you actually ensure that the binary copy correctly, but I just do this anyway. And the wrapper script you are seeing here, this helps you turn command line argument into the IPO parameter file. So if you go through here, this script just read in the different parameter from command line, and then turn that into this here doc here. Right, so the yellow things you see here, this is the IPO parameter file. But using this wrapper, I can read in the command line argument and then split out this IPO parameter file on the worker node. Okay, and then I guess the next thing I want to show you is the submission script. So this is the Conda submission script. So for example, we want to copy the executable, that is the wrapper. We need to send this argument to the wrapper. So the wrapper will read in this command line argument and then turn that into an IPO parameter file to help you run. I actually say don't transfer the executable file. And I think the reason is because I want to copy the whole directory, the whole bin directory, including all the helper scripts. And then I want to transfer the output image.h5 into my submission directory with a specific name. So I'm mapping the parameter of my wrapper script into names of my output file. And then I also have this log and error files. Because this is a standard CPU code, so I just want a normal worker node. I need 4 GB of memory because my simulation image has pretty high resolution. And then I mentioned earlier that if you do not use the static linkage, then you will need to use Singularity container to ship your environment. So you can require to use Singularity container on your worker node, and you can specify what kind of image you want. Now, another thing is not OSG jobs will run very smoothly because this is distributed to many computers across the US. Some of them could have bad nodes. Some of them could have bad files. So whenever your job fails, OSG Conda is smart enough to put that on a whole stage. And then you can, using this flag to specify how do you want to restart your job. For example, here, I believe I asked you to wait for 60 seconds before retrying. So this is super useful when you need to run many jobs. And then for this submission script, I'm just sending a single job. But for the GL Monty calculation that I described earlier, I actually will submit 16 jobs at the same time in order to split one big job to many smaller ones. Okay, so that is the submission script. I won't dive into detail of all the other scripts, but let me just try to use it to do a job submission. So all you need to do is to run this batches script. So this will take a long time because you actually need to go through the file system to look up your input file and then figure out what is the M unit that Angela asked earlier, what is the MD5 sum of your input. But let me just quit that. And now I have a big batch file. And then my script is also smart enough to split this into multiple jobs because I don't want to overfill my hard disk, my allocation. So you actually submit this to smaller jobs, and then I can submit each of them one at a time. And even though I quit earlier, I end up gathering 1,700 jobs, and now they are all submitted to the OSG pool. And if I use CondaQ, and you can see they are now idle. They are waiting to be started. And usually you will take a few minutes and then they will start to move to the run state. I don't think I have time to wait until them to get started. So let me just go back to my laptop and then just show you how this image will look like. So once the jobs are done, you will get your output files with this name. You'll remember the transfer remapping I was doing. So these are the name of the output files you will get. And now let me just go to my Jupyter Notebook. We have a couple of tools that will you'll read in this output file, and then you can look at what is the flux. So the energy for the for this is actually match the requirement that we want it to be, and then you can also visualize this image. So this is, I believe, in a lower frequency that the accretion flow is optically fake, so you cannot see through the accretion flow, and you cannot really see the black hole shadow. But if you go to the right wavelength, then you can see through all the plasma, and you'll find this shadow here. So I think I already run out of time. So let me just stop and let Rob you continue.
Thanks, CK. And what I'll show now is this run through a gateway. It's not the large simulation with 1,705 batch jobs like CK did, but I'll show you how to run a single job, and this can be scaled up as we go through. We've done just kind of a proof of concept here that can be done. But first, I should say what a science gateway is. It's basically a user interface to the cyber infrastructure resources. Brian said that the access point is your home on OSG. I see the gateway as kind of the front door to the OSG, but this abstracts all that complexity of the cyber infrastructure, like the OS pool and like the other computing resources you may be behind a web-based interface. It's designed with the user experience at the forefront, so we really take some time to talk to and interview the people who are users to determine what their needs are, and it basically provides a entrance in a simplified web format version. It has the built-in visualization component, so you don't necessarily have to move the files anywhere. You can see them directly within the gateway. And it has the look and feel of the project, not necessarily the cyber infrastructure. So the basis of this is you can have your project or your gateway and your cyber infrastructure look much like the project, and I'll show that in just a moment. But you can go ahead, Christine. I do want to say this is built on a full stack in several different components within the gateways. We're using what is called Apache Aryavada as the framework. It has the science-centric user interfaces, which is based on Django, a custom security system for authentication, authorization, and secure data management. It uses the data services that are built into Apache Aryavada, as I said, execution services, which actually run the jobs within the cyber infrastructure. And then this can be used to access multiple types of environments, including cloud environments, HTC, HPC environments. It can leverage container infrastructure, which we'll need to do moving forward. And you can go ahead and go, Christina, and if you give me access, I will share my screen here.
Yeah, you should be able to.
Okay. And you should now be seeing the gateway, or my desktop from the gateway, as I'll move some files around. So this is what the gateway looks like. Feel free to follow along at this eht.scigap.org. And if you have any single run jobs, you can actually do them through the gateway. But this is what the gateway looks like. We have the Event Horizon Telescope information here. What is EHT, along with the logos of the institutions involved. So this looks like a general front-end interface to the EHT project. However, what's behind the scenes is much like what CK just showed. We go up here and we can log in. This will take us to a CI logon, and you can log in with your institutional credentials if you're part of the CI login group. I've already logged in previously today, so I just picked Indiana University and the login, and this will take me to a dashboard where I will see the applications that are available to me. We've done this, as I said, a proof of concept, so you have just a few here in OSG test, which is a very short job that just basically pings the resource. But then the IPOL project is here. This dashboard, you can also see the recent experiments or recent runs that I've done during the last couple of days as I've been testing this. So in this case, if we wanted to run an IPOL job, we click on the IPOL project here, and we get a user interface. Looks like this. It gives it a generic name. You can change this to something more descriptive if you'd like. We'll run in the default project. The input files, you can move directly here. I'm going to do this with just a test file here. You drop the input file here. Then you can, as that uploads, change the default parameters, the R-high ratio, the viewing angle, and the row 0. I'm going to use the defaults here in this test, though those can be changed to whatever you may want. We've already pre-selected the OSG pool. You can see there's Access CI resources are available here also, but for this demo, we will use the OS pool. When you use the OS pool, it automatically populates the node count and core count, much like the others, but you can modify these parameters to something that you may want. Again, we'll stay with the defaults in this case. I do want to receive an email when this finishes, which is just a checkbox here, and then we save and launch, and we'll get a status screen directly from that. These top portions are going to be the output files when the job completes, including the HD5 file for direct download. It will generate a plot, and I will show that in a minute, along with the parameter file and any standard out or error that comes. As you can see, this now has a executing status, and it's queued or idle in OSG. This will take, usually it takes 2 to 3 minutes for this to return. But while we're doing that, there's also options here. So if I decide that I'm doing this run and I want to share it with some number of people within the group, for example, if I want to share it with CK, I can choose his ID, and since I'm doing CHs, I'll also share it with Christine. And then when I save this, now this will appear in their desktop on the in their experiment desktop, so they can see this run here that was started by me over on their recent experiments. It will have my name on it. So as you can see, I have a status here. This is still executing. And while we look at that, so you have the user management built in if you want to share with somebody else who is also using the gateway. We'll take a look here real quickly at the administrative functions, though not everybody will use them. There are built-in administrative functions that allow you to do user management, see some experiment statistics based on parameters that you set. This takes just a moment, but you can see here over the last couple of days, we've been doing some testing. So you can see how many experiments have been set for the administrator. It has a credential store along with mechanisms for adding additional resources. If you want to add something beyond the OS pool, in this case, access resources or even local resources or some commercial cloud resources, there's a mechanism for adding additional resources to your pool. Again, you select those at the beginning of the job, which one you want to go at. There's potential storage resources and a place to manage the notifications, basically, so you can send the user something out if the gateway is down for maintenance or whatever it may be. So you have the administrative functions built in. So let's go back to my workspace here, and if this is still executing. This is the job that I just started a few moments ago. You can see here I have a place now I can download the image. We have some Python plots. I'm not exactly sure what this is showing here, but you can see that the plots are directly available within the interface along with the parameter file the CK showed earlier, and your error and output, and some details of the information. Now, this can be used for single jobs at the moment. It does do an automatic MD5 checksum of both the input file and the IPOL application to make sure that they're legitimate when they go there. And I think that's about all I wanted to show, but this interface, again, is available. We will need to work with probably CK or others to see how to do a larger batch submission than a single file. Right now, this is, again, just a proof of concept. It does use the OSG or the OS pool in the backend to run these jobs and return the results. I'm going to stop sharing here and let Christina go back to the slides. And just a high-level architecture here, you can see the user interacts with the gateway. It has those Apache Aryavata middleware services built in that do all the various management and orchestration on the gateway. It accesses the HT Condor access point, which is hosted on the Jetstream 2 cloud infrastructure, which is part of Access, where it then accesses the Open Science pool. It can also, as I said, use access resources. It can access resources and other resources, whether they're local computing clusters or cloud computing clusters. And you can go ahead on, Christine. And just to summarize here what the gateway is, it's the web-based interface to the OS pool resources in this case. It's built on Apache Aryavata. And Apache Aryavata is highly customizable. We can do all the various management, but then adjust the workflows as to what is needed with the group. In fact, there's documentation for the users and potential developers of applications that run on the gateways for how to do this, along with administration. It also has some monitoring tools and security built in. The IPOL application, as I said, was a proof of concept. We'd like to hear from the community the other potential applications. I know there's 4 that CK mentioned, but there may be others out there that someone would be interested in running through a gateway, and we'd be happy to work with anyone who would like to reach out to us for that. We do expect to use container Singularity or Apptainer containers in the future. The demo right now is built on a direct submission and direct transfer, and setting up the environment, including the Python environment for the plotting when you arrive or when the job arrives on the site. We expect that moving into the future that the containers will, or the Apptainers will be the direction that we'll need to go for manageability. But we already have that support for containers within Apache Aryavata. And as I said, we're happy to do targeted follow-up for users, administrators, developers who might be interested in accessing the OS pool through this mechanism. And I think that maybe, and I put the links to the documentation here for users, administrators, and developers if anybody wants to look deeper into how to use these Apache Aryavata gateways. And I will stop there.
All right.
And give it back to Christina.
Thanks, Rob. So for everyone who's on the call, hopefully that was a helpful whirlwind intro to what's possible in terms of managing your computing. So we wanted to give some concrete next steps to getting started for kind of both of the options that were demoed today. So anybody can apply to use either the OSG Connect access points, which you saw in CK's demo, or the gateway developed by Rob and his team, which, as you noted, is still kind of in the development stage, but I think they'd be very interested in your feedback and suggestions. And then for both of those, here's information about actually applying for an account and what that process is like. There's a sign up link on this OSG Connect website page that you can use. You'll be contacted about a consultation. Again, the materials from today's demo could be a starting point once you kind of get on the system and want to get going. And then talk to Rob and his team about being part of the process of getting the gateway up and running. So there's a contact email here. And we have some links and contact information. Just in general, if you're not sure where to start or what to do, reach out to these addresses and someone will be in touch with you. So that's the information we wanted to make sure we got to before the end. So any of you can get started. I'll also mention that the post-webinar survey has been put into the chat. And we'd really welcome your feedback via that mechanism. So for all of the folks still on the call, please fill that out before you sign off today. And with that, I'll leave up the acknowledgement slide. But Brian, CK, Rob, any questions or things you want to address before we sign off for today?
So I will say that they can apply for an account at the EHT gateway. There's a register and a login button. Feel free to sign up for an account and look around there and do things. Again, the only thing right now is it can run an individual job, but we will quickly make the adjustments as we move forward into being allowed a batch set of job submissions.
Yeah, I applied for an account yesterday. So
yes, and I just shared my experiment with you. So now you have some data there.
Yeah.
So I see in the Q&A, Abhishek actually asked a really great question. It's actually a kind of a classic question, which is, how big is the OS pool? And since I can't type fast enough, I figured that I can answer it live. And like any good expert, my answer is it depends. It grows and shrinks based on kind of supply. So for example, yesterday we took, there was 12,000 cores in San Diego that got turned offline because it was really hot there and the campus needed the extra electricity to run campus. So it does fluctuate quite a bit. That tends to be outside your control, unless if you say can have some local compute resources at your university that you can put into the pool. And then of course you can set those up so they only run your jobs. But however, a lot of times there's a lot of control that you have over the demand side. So CK gave example of a job that was statically linked, didn't necessarily require Singularity, so it didn't need any Docker or container technologies, and required, I think, only 1 GB of RAM. So kind of the smaller and simpler your jobs are, the wider range of resources we can put them on. So for example, the 12,000 cores I just mentioned at UCSD, right now they don't have Singularity on them. So there's no containers, so only people who statically compile or bring in their own dependencies outside the container actually get match against those. So a lot of times the things that's in your control is, can you make your jobs simple and small? So my mental image is that they can fit into the cracks like sand, as opposed to very large rocks that are more difficult to schedule.
Thanks, Brian. So do we have more questions? So if not, then thank you very much for all the attendees for coming. And of course, also thank you, Christina, Brian, and Rob for your wonderful presentation. So yes, so again, please fill out the survey that will help us improve the upcoming webinar. We are also planning for the other webinar in this fall. They will be mainly about technology, and we will announce them shortly. So please stay tuned. And also, last but not least, let me post another link to the chat. So that is the YouTube channel of the Black Hole Pioneer. So you will be able to review this webinar and also watch the previous one. Okay, thank you very much, everyone. I hope you have a good day. Bye.
Bye all.
Thanks. Bye, everybody.